29 January 2026. First point, assembly of the pressure sensors. It is 3 p.m. Let's start.
I am Alessandro Chiolerio, coordinator of the COgITOR project. The project started in 2021 and collected so far 25 scientists from different countries in the European Union and also beyond, including chemistry, physics, material science, computer science, and smart materials.
Okay, first sensor soldered.
The development of liquid-state systems enabled us to create something that is able to compute and store information using simple colloidal suspensions. We also developed systems able to generate electricity out of thermal gradients, self-healing skins to protect and encase the soft robot, pressure sensors based on nanocomposites, and also proprietary chips, so standard electronics that could enable the processing of the information within the liquid medium.
Last sensor.
My specific role was that of creating innovation. That means that I could devise something that was not yet developed or studied or explored by previous researchers, and then plan the practical creation of the system.
Today, January 30, half past 10 a.m. and we are trying to assemble the TGC cell. These cells are responsible for generating energy for us from the heat. I'm Afshin. I'm a physicist. I'm come from Iran. And my role in the COgITOR project is a system integrator. For me, COgITOR is going to be a very great revolution in the robotic world. This will be an inspiration for all scientists because, as the first time, we made something no one expects to have. We made a robot from a complicated liquid, and all the parts in this project were soft. This gives us opportunities for future to have a more relaxed and more comfortable and probably more sophisticated world to live in.
I did the calculations of the volume changes during a temperature increment from 20 to 90 degrees Celsius. And by surprise, the volume of water increases by 2.3%, and the volume of ferrofluid decreases.
Decreases?
Yeah. So...
Why decrease? Because of the iron?
Because the magnetite has a much lower, like 1 order of magnitude, and 30% volume of magnetite is a lot, so it actually it shrinks the ferrofluid, and the water expands.
The transdisciplinary aspect has been so much relevant and important, so achieving a common language that could enable the communication between the different levels of expertise and the different subjects. So we get very close to the end of the activities, and now in front of me I have the root circuit connected to the COgITOR board, and now I'm running the code and it's working.
I'm Charandras Mohan. I did my PhD in Spain and I flew to Genova to be involved in the COgITOR project. My work primarily was to design a custom chip that can emulate user-defined resonance states in the intelligent colloids and to harness it for applications like bio-inspired image learning.
I am Marco Crepaldi, and I am the head of the Electronic Design Laboratory facility in IIT. Our work in the COgITOR project was both interesting and important, in my opinion, because the first thing we have done is to enable the experiments on ferrofluids using a patented technology which is based on the RF impedance spectroscopy and DC stimulation. We made up a setup comprising some commercial boards, and a software which is capable of planning experiments using a language we have defined on purpose for this. In such a way, we could record a lot of data from the ferrofluids and understand what was going on. It was completely blank, it was completely unknown.
It might seem too much futuristic, but nevertheless, funding this kind of research at a systemic level would enable us to develop and to patent many technologies that could have a real practical application even on Earth, and moreover in the computers of the future.
My name is Adriana Nunes. I'm from Brazil. I'm a chemist, and my expertise is material applied in new technology. I developed a self-healing skin that is an important part of the project. This skin is used to protect the robot and has self-healing properties.
I'm Diego Torazza. I'm a mechanical engineer. It's about 20 years that I work on mechanical design, helping research scientists. Since the beginning, when I was involved in this project, I understood that yes, there was complexity, but there was also a nice potential in trying to impress the fluid with light. So that is a sort of optical memory in the fluid that could give very interesting development in the future.
My dream is to use it in our daily life, for example, spreading in the forest, anywhere we want, and collect the information. And that means we can talk, we can understand nature in a more easier and more complete way ever.
Nature knows how to compute also with liquid. We had a very nice, let's say, idea, but of course limited to the time frame of the project, on how to approach to computing with liquid. But of course, as human, we don't know anything about that. So in my opinion, COgITOR can lead to a different way to interpret computing in a substrate which is not fixed.
The moment I understood that actually it was possible to store and retrieve information in a liquid was amazing. That was 2 years after the beginning of the project. And then we started writing the paper, so putting down all of these measures and informations that we collected during the following months. And at the end, what we did was to integrate and put this, what was found, the memory and liquid computing device, together with the other parts developed in other countries. For example, the energy harvesting modules, the sensors, and also the skin, the self-healing skin. All of this now has become a practical and macroscopic object that we can also test and play with. Finally, we are in the last phase of the project. We are in a company that is specialized in the production of industrial plants, and we are going to put the COgITOR prototype inside the chamber, submitting it to extreme pressures, temperatures, and magnetic fields. So we're going to test the resilience of the system and the functionality in these difficult conditions. So, fingers crossed, if it works, this is the premise to put our COgITOR prototype into another scenario, for example, the depth of the ocean or an external planet. After these 5 years, we achieved the point. Still, many open questions are there, and the development that we have achieved so far has still open routes that we want to explore. So it's not the end, it's just the beginning of new proposals, new ideas that will come in the future.